All right, welcome back everybody. Again, what we are going to be doing in this video is we're going to finish up the Unit 5 review. So this is the last 3 pages. So we left off with question number 63. We finished that up. Now we're going to finish this up. So let's go ahead and finish up this review. Okay, so here we're just asked to find critical numbers. Sounds easy enough. Critical numbers are where the derivatives are equal to 0 or undefined. So what we do is we begin by taking this derivative and seeing where this is equal to 0 or undefined. So I can take out a 12, in fact, of this one. And so that would leave us with x minus 2 plus 3. And so we will have critical numbers at positive 2 and negative 3. So only x's, positive 2 and negative 3. Booyakasha. Which of the following is true? It is saying that f prime is greater than 0 for the entire number line. It looks so, but that might be equal to 0. That might be equal to 0. I'm not sure. So I'm going to say maybe right now. I'm going to say maybe. So stand by on that one. F double prime is negative from negative 1 to 0. That means concave down. So this is saying this is concave down on the entire interval from 0 to negative infinity to 1. And yeah, that is concave down right there. That's fine. Let's take a look. F double prime is positive, aka the picture is concave up from 1 to infinity. Concave up. Yep, it is concave up. So I see that 2 and 3 are at least true. So whether that is equal to 0 or not, that is the million-dollar question on if the answer is B or if the answer is D. And I'll say that, I don't know, it looks pretty flat right there. It looks pretty flat. It looks pretty flat, so I'm going to say that the derivative is equal to 0. So that means no, it is not purely greater than 0. So I'm going to say 2 and 3 only. I'm not exactly sure what I said on my answer key, because wow, that derivative, I don't know. It's close. It's a close one. Okay, G is continuous and differentiable with on the interval from 2 to 6. Okay, so all right, let's talk about this. The minimum value of G on 2 to 6 is 1. Now it looks like it, but I don't know what's happening in between all of these values. I don't know what's going on. Because, for instance, the picture could do something like this. It could be doing like, okay, it's at, so when it's at 2, 1, 2, 3, 4, 5, 6. So when it's at 2, it could be at 7. 3, it's at 4. 4, it's at 1. 5, it's at 4. 6, it's at 7. But I don't know what's going on. What our pictures could be doing is, I don't know, something crazy like this. I don't know. So can you definitively say that that's a minimum? Hell no. So that is not definitively true. The maximum value is 7. No, that is not, again, it's not definitively true. there exists a number c within 2 to 6 for which the derivative at c is equal to 0. All right, so that's going to be true. That's like Rolle's theorem right there. And so what this is saying is this. So at 2, okay, this is at 7. And at 6, this is at 7. So the slope, the average rate of change, is equal to 0. So because it's continuous and differentiable, that means there is a point somewhere in between 2 and 3, for which that is going to be equal to the average rate of change, aka the slope of the tangent. All right, which this is like an f prime of c. There is a, or I guess a g prime of c. There is a g prime of c equal to 0. Thus, it follows Rolle's theorem, which is the same thing as mean value theorem when they're equal to 0. Last but not least, let's just disprove d. There's a derivative. The derivative of d is less than 0 for 2 to 4. 2 to 4. Not for the entire thing. Again, it can go up and down. The slope can go up and down and everything in between. And so you'll have a slope that is positive. You'll have a slope that is negative. So it's not definitively purely negative. So it isn't just going downhill. Okay. Consider the graph of this, so f is y, okay? If the function f such that f prime and f double prime are defined in the region around 2, then which of the following must be true? Okay, so 2. Let's take a look at 2. All right, so what do I notice about f? F is equal to 0, okay? What do I notice about f prime? F prime, this thing is decreasing. Okay, it's decreasing right there. This thing is decreasing and it's concave up. So the derivative is this the slope, and I see that since this is decreasing, this is going to be. I'll just write it like this. This is going to be a negative number. This is going to be a negative number. It's negative. The slope is decreasing. And because this is concave up, that implies that the second derivative is positive. So, putting this all together, I would see that f1 is less than f, which is less than f double prime. Because this is negative, this is 0, and this is positive. So that's kind of the way it works. And so all I have to do is identify the thing that pretty much says that. So f double prime is less than, new. F double prime is less than, new. Those things are equal to, new. Double prime is bigger than the regular f, yes. The table below shows the behavior of a function that is continuous on the entire real number line. For the function f of 2 is equal to 4, all right, and the limit as x goes to infinity is equal to 0, so that has a horizontal asymptote that is equal to 0. I just couldn't live with myself if I didn't try to understand what this picture looks like. Okay, so we have this x of 4, all right, and so as this goes to infinity, as it goes out this way, as this goes to infinity, the limit of f of x as it goes to infinity will be equal to 0. So this is going to have some sort of like horizontal asymptote. It'll get closer and closer and closer to 0. All right. When x is less than 4, I'm sorry, x is 2. So what do I notice about this is that when x is less than 4, the slope is positive, and the second derivative is negative. So that means it's increasing concave down. It's increasing concave down. Okay, so the derivative doesn't exist, and the second derivative doesn't exist, obviously. So this is going to be like a corner or something like that. It's continuous, so it's not going to jump, so there's going to be some sort of corner or something happening there. For bigger than 4, the first derivative is negative, so that means it's decreasing, and the second derivative is positive, that's going to be concave up. In my mind, that's what it does. Now, yeah, I guess that's what it does. All right, so what values of x is f increasing? So that would be from negative infinity to 4. Okay, that's where it's positive. Does f have a relative maximum at x is equal to 4? Explain. Because the derivative is not equal to 0, great, Moogly. This one is a tough question. Okay. Yeah, because it's critical. Yeah, okay. So yes. Okay, so there is a critical point, and it's continuous. So that means that this doesn't break stride. So it is defined, and so it's increasing going up and decreasing going away. So it's a critical number because it's the derivative is undefined. It's and then it switches from increasing to decreasing, or AKA the first derivative switches from positive to negative. So that implies that it is a maximum. It is defined as a maximum. It's just, it happens to be a corner. Okay, if possible, name the x-coordinates of the point of inflection on the graph of f. Justify your answer. So here, the point of inflection would occur at x is equal to 4, because the second derivative switches, again, positive to negative, negative to positive, and it is defined, so it switches from, in this case, negative to positive. Does the mean value theorem apply over the interval from 3 to 5? No. So again, the two criterion that have to be involved with the mean value theorem. It has to be continuous on closed, aka square bracket 3 to 5, which it is. It's continuous, so that one's good. Okay. And then it has to be differentiable on open 3 to 5, which it isn't. It is not differentiable because of the sharp corner right there. So the mean value theorem does not apply. Okay, sketch a possible graph. Well, there you go. I sketched it. Okay, so this is a graph of the derivative. So don't think that this is a graph of f. This is the derivative. So things that, again, that we know about the derivative is that if the derivative is positive, that means the original is increasing. If the derivative is negative, that means it's decreasing. So that means when the derivative switches from positive to negative, that'd be increasing to decreasing, that is most likely a maximum. And then if it switches from negative to positive, that is most likely a minimum, most likely. When the first derivative is increasing, that implies that it is concave up. When f prime is decreasing, that means it's concave down. So that implies that at any max or min is a point of inflection. Okay, at any maximum or minimum, that would be a point of inflection. So find f prime of -1. So f prime of -1 I feel like this has a slope of what? -1/3. So -1/3. So at this point, f prime of -1 would have a value of -2/3 at that point. The second derivative, so the derivative of this derivative is what is the slope? What is that slope? And as I just got done saying, the slope of that would be -1/3. Rise of -1 on 3. At which x values does f have a relative extrema on the interval from -5 to 0? So extrema would be, again, where excuse me, the derivative switches from positive to negative or negative to positive on the interval from -5 to 0. So the only place that that takes place is at this -3. So why? Because the derivative switches from positive to negative right there. So this more specifically would be a maximum. Find all intervals of the graph of f, which is concave down. So this is asking, where is this picture physically negative? Excuse me, no. Concave down is where f prime is decreasing. So it is decreasing starting here. It's decreasing, decreasing, and then decreasing. Those are all the places that it's decreasing. So this is concave down on the intervals from -4 to 0, and also 1 to 4. How do I know? Because the derivative is decreasing. Find the x-coordinates of which the point of inflection. So again, inflection is where there's any maximums or minimums on here. So points of inflection will occur right there, and right there. All right, so any maximums or minimums is where like increasings turn into decreasings or decreasings turn into increasings. So that's going to occur at -4, 0, and 1. All right, so that is where the derivative switches from increasing to decreasing or decreasing to increasing. Okay, if g is equal to this, is g increasing or decreasing at x is equal to pi over 4? All right, it's kind of a weird question, but I'll handle it. So increasing or decreasing is the derivative. So let's take the derivative of g. So that would imply the derivative of f, and the derivative of this, which is going to be 2 sine x times negative, excuse me, no, times cosine x. Chain rule. And so they want to know what is g at negative pi over 4. All right, let's take a look at a unit circle. Negative pi over 4 is when you go backwards, and so that's negative pi over 4, which has the square root 2 over 2, negative square root 2 over 2. So this is going to be 2. The sign is negative square root 2 over 2. The cosine is positive square root 2 over 2. And I'll come back to the f prime here in just a second. Let me finish my thought. And so this is going to be multiplied by 2. So this is going to be a minus. And this is what, going to be 2 over 2, I believe. So that eliminates, that multiplies, so that's going to be 2. And so that'll be 2 over 2. So this is going to be minus 1. Okay, the derivative when x is equal to negative pi over 4. Let's get an idea of what the hell that number is. So negative pi over 4 is negative 0.7. Negative 0.7. Okay, ish. There. And so what this is in the realm of, this is approximately, approximately negative 2/3 or something like that. Like, approximately. I'm not exactly sure. Negative 2/3, something like that. So this is approximately negative 5/3 or something like that. Something along that line. All right, so anyways, is g increasing or decreasing? So the one thing I know for sure that this is negative. This absolutely is negative. So what does that say about g? G is decreasing. The derivative of g is negative, thus g is decreasing. And that's it.